G'day and welcome back. Today I've got a Philco radio. It's from New Zealand. Now I started doing this radio 2 days ago and I was suddenly struck down with a mystery virus. So I was spent 2 days in bed. I just got out of bed this morning. I'm starting to feel better now, so I'll have a go at this, but if I sound a bit flat, that's why. This belongs to a friend of mine. He's given it to me to quickly just get it working. He's got the case. I don't have the case. So he just wants me to fix it, get it running, and he'll put it back in the case. He'll polish the case up. It's a 5-valve set, so pretty standard. 2-gang tuner. Yeah, there's nothing unusual there. Pretty big capacitor on the end there. It's just got volume, on, off, and tone and tuning. It's got New Zealand stations on it. They use the same numbering system we do with a number and then 2 letters. And it's also got the frequency around there, which is something we don't do on Australian dials very often. I'm not sure why Philco were in New Zealand. I'm not sure they were in Australia. I've only seen them in New Zealand, but that may not be true. They may have put radios out here, I don't know. I'm interested in this capacitor. It's pretty big and it's got 40 there. I think it's 40 UF and 350 volts. So it's pretty high capacitance and low voltage. It says here this receiver operates on 230 volts. I assumed New Zealand was always 240. They must have been 230 when we were 240. It says there, so Dominion Radio and Electrical Corp. They're in this place in Auckland. I am not pronouncing that. There's no other marks on this set. It's got this on the end, but that says watts 40, so that's nothing. Looks quite a neat little radio. It's got no valves in it. Yeah, like modern, late, maybe early 60s, late 50s. I'll flip it over, have a look underneath. And straight away I see a potential problem. It looks like this transformer's been running too hot and it's melted the wax. Now that doesn't mean that it's no good. This means that it's got too hot and the wax has run out of it, so the transformer might still be okay. Apart from that, it looks pretty good. It's only got 3 capacitors that I can find. There's a disc capacitor over here. Some funny little capacitors down here, I don't know what they are. So not a lot in there. A tiny little oscillator coil. Yeah, okay, so pretty simple set. There's a stray wire coming off this antenna coil. That's the antenna wire that comes out of the set or goes to the antenna. So this is going to the same place. So it's probably had a plate antenna on top of the radio and that's been disconnected. I'll have to find out about that. It all looks pretty good. I need to work out why that transformer's melting. I also need to find out what radio it is. I haven't got a clue. I haven't got the case and it doesn't say on the back. So I'll have to go and do a bit of investigating, find out what model it is and see if I can find a circuit diagram. I found a circuit diagram. I forgot my friend gave me this box and it's got spare valves in for a Philco Alabama. So I looked up Alabama and there it was. I have 2 schematics. I got them off the New Zealand Radio Project website. This one's dated 61 and the one underneath is dated 57, so I don't know which one I've got. I'll use this schematic for the time being. A single secondary, no center tap, and they've joined both wires onto the anodes of the EZ80, which is a 6V4. That runs down to 40 microfarad capacitors too, so that's why they've got such big capacitors, because they're using a half-wave rectification. Typical layout there, 200 volts up there. There's another capacitor there, that's 20 microfarads, so they're really trying to clean it up. There's the tone control, there's the volume control. Look, it's a typical layout. There's the 2 detectors. This will be the AGC. There's the big resistor. Capacitor goes off to the grid, and this one will go up here to the grid. Yeah. So nothing here really. Oh, there's the aerial plate. So it does have an aerial plate. Alright, so that's what that wire's for. Alright, nothing there to look at really, is there? Let's have a look at the radio. Here's some photos I found on the internet of these radios. They look quite nice, aren't they? Nice little radios. Nice colours. They're a plastic case, they're not Bakelite. I also found this photo and you can see the red wire running up to the plate antenna glued to the top of the case. But yeah, nice looking little radios. I like these. I want to check out this transformer and make sure it's okay to put power on. I'm just going to melt some of this excess beeswax off here, or the wax. I've I've got most of that excess wax off here, so I'll buzz this out and make sure it's going to work and hasn't shorted. I've checked the transformer and I can't detect any short circuits. I'll put some power on and we'll see what this little New Zealand radio can do. I won't leave it on for long. Alright, should be warmed up. I'll turn the volume up. Oh, there's something there. That's tone. Yeah, that's tuning. Oh, this there.
G'day, you're back with the Tum and Phul morning show. That was Danny Minogue with This Is It. Did you like that, Phil? Yes, Tim, it was choice. I agree, it was choice.
Let's try something else.
Introduce our special guest, visiting us for
That's
the
the
sixth
same
time
people.
since his impressive electoral victory. It's the Prime Minister, Jim Bulger. Hello, Jim. Hello, Tim. Hello, Jim. Hello, Phil. Tell us, Jim, how was your visit to Invercargill? It was choice.
What's going on? Have we been taken over?
Of our patented Tum and Phil wacky phone calls. Today, we're calling up the Missing Individuals Information Hotline to make an inquiry, but with a twist. Phil, that's right. Instead of inquiring after a missing individual, we're going to ask if they've seen Tim's missing jandals. Shh, shh, this should be fun. Hello?
Well, this radio's no good. It's living in the past. Sorry, time to come clean. This radio isn't actually powered. I've run an independent supply to the lamp there to make it glow. They were little comedy skits that two Aussie blokes used to do. I don't mind having a go at the New Zealanders. We're brothers, but they keep beating us in every sporting event they can think of. There's only 4.5 million of them. Anyway, I'll set it up so we can really try this out. I'm all set up for real this time, no fooling. And we've got it on dim bulb there. The transformer did check out alright, so power's on it now. And it hasn't dropped it a whole lot. It's 216 volts out of, 230? And 25 watts, that might be a bit high. The globe's on, but it's only mild, it's not too bad.
Tomorrow, Brisbane will reach a top of 31 degrees. It'll be 33 in Ipswich, 20.
Federal government insists it's on track to meet its climate targets despite stinging criticism from the United Nations. Jess Davis.
With is below 1 metre.
Talking 3 back up side, Chloe Ann.
29.
Okay, that works well.
A growing number of G20 developed economies have announced meaningful emissions reductions by 2030.
Tone works,
There were
volume works. It's perfect.
Energy Minister Angus Taylor says the focus should be on Ukraine.
It's pretty tone deaf to focus.
So, well, it's working pretty well. I'll put it to full power just for a second and see what wattage we're pulling. Should be 40. Oh, it's only 43. It's dropping now, the capacitors are warming up. So nearly 300 milliamps. It's not too bad actually, is it? I've left it on for a little while. It's dropped down to 40. Yeah, it's running pretty well. I've had the radio on full power for about 2 minutes. This dropped down to about 39 watts and now it's just slowly creeping up. So we're getting higher and higher. So I'm going to turn it off before I damage it. It would appear the capacitors are starting to short. I know it works now, so I think I'll do the normal things. Change the electrolytics, change the 2 or 3 capacitors that are in there. Give it a bit of a clean up. It's not too bad, but it just needs to be dusted. Probably check the alignment and I think she'll be good to go. I'm having a better look around the bottom here again. I'll replace these 3 capacitors here. Now there's a little green cap in here that I didn't see before. It would have been prudent to put a bit of insulation on that lead, you would think. I said earlier I'm not sure what these were, but because they're capacitors I knew that, but I haven't seen that sort of style before. But I'll lift the leg on one and just test it, make sure it's okay. This is the base of the electrolytic can here, and I think there's 3 capacitors in there. It should be a 40, a 40 and a 20. Now I'm thinking of restuffing it. The other option I have is to put a tag strip along here and then mount 3 capacitors on it. But it's much more satisfying to restuff the old one. I think everyone agrees with that. Well, maybe not everyone. It only has little tabs there that you straighten up and should pull out. So that's the first thing I'll do. I'll take this out. I'm going to bend these tabs straight so I can pull the capacitor out. One of them's got an earth wire on it. I tried to take one of these capacitors out on the RF8 amp I did some months ago now, and I tried solder wick and all sorts of stuff to clear the solder off the little tab that I had to remove. I was at a radio club auction a couple of days ago, and one of the chaps said, "Why didn't you try a brush, horsehair brush?" I said, "That's because I didn't think of it." Thank you to the chap at the auction. I've straightened the little tab, so that should pull out. Look at the wires on it. I have to cut them off when I get it out. Yeah, there it is. Okay, I've got it out. It is 40, 40 and 20 as I thought. It says May 1958. It says red outer is 40 and the plain inner is 20. Now when you look at the bottom, it's got plain, yellow and red, so it doesn't match up with what's on the can. Doesn't matter, it's going to get thrown out. It looks like it's trying to escape the inside. Anyway, I'll take this apart and clean it up. If you watched the video I did 1 or 2 videos ago, I tried to machine quite a thin capacitor away just the edge there so I could pull the innards out. And of course I couldn't hold it. I wasn't able to use this center to stabilize this end because I wanted to keep the end. Now this end I don't care about, so I've rammed a center in there and that should help keep it stable. It's also a bit bigger in diameter, so it should be more stable again. So I'm going to attempt to trim the end off. I think that's it. I think I've got through. There's what's left of the rolled over edge. It just pretty much fell off. I'm going to try and get the little retainer ring out here. There we go. Right. I assume this will come out. Maybe. Maybe not. I might have to drill it out. Yeah. Okay. Alright, I'll drill a hole in it. I'll drill a hole in here and I should be able to get something in there to rip the insides out. I'll use a bigger drill and try and drill out the middle. I'm resorting to violence now. That's what I wanted. There she goes. Should be able to get my pliers in here and twist it, and that all should come out. There it goes. I think it's left some down the bottom, but that'll just clean out. It appears they've got some sort of tar or something in the end there to fill up the gaps, I think. Anyway, I'll keep working at it and clean it all out. I'm not sure what this is. It's like a plasticky stuff, so it seems to be melting in acetone, so I've put some in there. I've filled it up with acetone. I'll put a little cover on it, leave it overnight, and then tomorrow I can restuff it. In the meantime, I'll get rid of all this stuff in here. You don't know what it is. It's probably carcinogenic. I'll go and have a good scrub up, and I'll see you in the morning. I managed to scrape out most of that black plasticky filler, whatever it was, so it's reasonably clean in there. It's good enough. I've also made a capacitor pack up here, and there's 2 47s and there's 2 10s there to make a 20, and I've put little tags on the end there so I can solder to them. So that's come up pretty good. To make sure nothing shorts to the case here, I've got this press board here which is an insulator, and I'll put that in there. Looks like it's off the Kellogg's box, but it's not. It's specific for the job, and that should fit in there. There we go. And then this ring goes on here, and I just need to line it up that way, I think, and it's finished, so that'll look all right. I need to roll the edges, but before I do, I'm going to glue these in, and I'll use a nice glue that'll hold it, because if this is rotated, if someone grabs the top of the capacitor and rotates that against that, these are going to short against the chassis. So I'll glue these in, and when they're dry I'll go out to the garage and roll them on. So I'll see you out in the workshop. Okay, I'm not in the workshop. The adhesive for the electrode cap takes about 24 hours to dry, so I'll have to set that aside. In the meantime, I'm going to have a look at these resistors and these capacitors. The 2 resistors next to the electrode cap were no good. They're under a bit of pressure where they sit, so that's probably why. I'll just check this one here, which is what, 4.7, and what have we got? 3.8. I'll just bend this over a bit so I can get to it. What's that, red, brown? That's 220. About 226, so that's okay, that one. I'll try this one. It's probably got a capacitor or something across it which may affect it. If the capacitor's no good, that's yellow, purple it is, I think, and orange. 47k, and we've got 59, yeah. Well, that one is crook. I might have to change most of these resistors, I think. So it looks like some are good, some aren't. I'll have to check them as I go. I'm going to lift the leg on one of these ERO capacitors and see what it measures. So put one on there, and on there. These are 0.047, I think. 0.049, that's pretty good. 0.048, alright, well they seem okay. I have no idea when they've been changed. I'm not sure, they're still pretty old. I'll put the mega across one at 500 volts, we'll see what that does. Yeah, that's fine, so that'll go to 1, there we go, yeah. So that's working fine. These are testing perfectly alright, so I could leave them there. I'll swap them out for a couple of Carl's capacitors and change these resistors as I need to. I'll come back when it's time to put in the electro capacitor. I've replaced the capacitors and any resistors. There wasn't that many that were wrong. I think I changed, what, 1, 2, 3, 4, 5 resistors, 3 caps and that cap there. So not a lot, but boy, it took a long time to do. Anyway, I got there, and the next thing to do is put the electro capacitor back. The adhesive is dried, so I can roll this edge. The last time I did one, I only used one piece of wood at the back here. I've put another piece this time so I can run it on 2 pieces of wood instead of the metal vise. Alright, here we go. Once again, that looks terrific. It's rolled over quite well, and once that's in the chassis you would not know it had been touched. Alright, let's give it a go, so I can line it up. Oh, there it goes. So all I've got to do now is twist it. That's good, nice and solid. You may not be able to see it there, but I put 2022 on the bottom of the capacitor there for the next bloke. This one here and this one here are 47, and this one's 20. So this is the wire from the rectifier, so that goes to the 40. This one's going up to the audio output transformer, so that goes on the other 40. And this one goes to the screens and powers the rest of the radio. There's a resistor between both these 47 capacitors. That makes up the pi filter. So that was 470 ohms, this is 1.5k, and that goes off again to power the screens, etc. Alright, bit of a task holding all that together. I'm going to put some solder on there. I'll come back and I think we're nearly done. That looks pretty good. I'll just pull that over a little bit. So no chance of shorting. Very good. Alright, I'll turn it over and I think I can give it a test. Alright, I'm all ready. I've got an antenna on it. On dim bulb, I'll put some power on. And that looks pretty good. Now it's warmed up and it's dropped it to 209. So before it was dropping it under that, it was about 180 odd, 89 or something. So it's not pulling as much power. Right, I'll turn it up.
G'day, you're
Stop it. Alright, for real, I'll turn it up. Oh, actually it doesn't work. It's dead. Oh, there we go.
In tears, but it was a deliberate act, and you don't often say that on a footy field these days. That was deliberate. There's no other reason for it. Kick off.
Supertramp, one of my favourites.
It was a coach and play.
Tab.
So Six La Mexicana is on her feet, but she's very, very bubbly indeed, and
yeah, okay, that's working as well as it was. Right, I'll put it on full power. Now before, that was heading towards 50 watts, was I think got up to about 46 something. So let's see what we got now. I'll just put this on about 230, there it is. And 35 watts, so it's down over 10 watts. So that electrolytic was no doubt leaking. So what to do now, I need to clean the base for this valve here. The other ones seem okay. It might have got a bit of something in while I was cleaning it, so I'll clean that out. I think I'll check a couple of voltages underneath just to make sure everything's running okay. Quick alignment, put the scale back on, and we're done. I've mounted a fuse in there. Before I go on, I'm going to check all these voltages, make sure they're okay. That's supposed to be 230, it's 251. Gosh. So through the resistor will be high, of course. That's straight out of the rectifier. This is after the resistor on the second filter. So that's supposed to be 210, I think. I'm not sure, this should be 180 or 200. It's got two different numbers on two different schematics. So it's 207, that's high. This here should be about 50, it's got 99, wow. This one's supposed to be, I think, about 50 as well, so that's 93. So something might still be wrong with that transformer. That's the filaments, 5.6, they should be 6.3. I've changed all the valves just because that's the easiest thing to do in a hurry, but it'll be the same, I'm sure. Yeah, 252 should be 230. I'll check the filaments as well again. They haven't changed, 5.6. So something's wrong. I've got 232 going in. This is going to run more like the 240 volts now. So that's going to go even higher than that. So something's not right. I'll flip it over. I'll run it for about an hour or so, just see what temperature this transformer gets up to. This has been running for about an hour. It's stabilized at 57 degrees. I've got a thermometer stuck in here, a temp probe, and I can confirm that's near 60 degrees just using my finger. So of course the radio is working. It's fine. The valve voltages are within the limits of the valves. The valves don't have an issue with that voltage. There's two things I can do. I can either rewind this or just leave it. Now I've contacted the owner. I'm waiting for him to get back. He'll tell me what he wants to do, if he wants to spend the extra money on getting this rewound. If he's just going to put it on display and turn it on occasionally, it's not worth the money. So I'll wait till he comes back to me and tells me what he wants to do with it. But in the meantime, I'm just going to carry on with it as it is. Here's the dial glass, and it looks pretty good on that side. But on the back, it's covered in dust, and this area here is pretty dirty. But the little transfer that's on there, or whatever it is starting to crack, and it's moving. You can see it doesn't line up there. So it's quite delicate. I need to work out how to stabilize it. I could try covering it in a clear lacquer, but it may start eating into the paint, so I'm not sure what to do. Another idea I had was perhaps some hairspray, so maybe I'll try the hairspray idea. That's probably the safest, but I don't want to get hairspray on this area here. Like this, I'll put something over here so I don't spray that. I'll see if I can get the dust off. I've wet this cotton tip applicator with a bit of saliva. Oh, look at that. Yikes. I'm not putting that back in my mouth. I thought it was clean, but it's not at all. There's little cotton applicators from just that little area there, so pretty dirty. I've cut a bit of cardboard out of a cereal packet. In fact, I've actually cut the ingredients out there. And I'll just give it a very light spray with this hairspray. I tried a little bit up in this corner. It hasn't affected it, so we should be okay. So I'll let that dry, and I might do another coat, but I think it'll be alright. That's got a nice even coat on it, so I'm going to leave it. I'm not going to put any more on. I'll put this back onto the radio. So I'm all set up. I've got my generator on 465, that's the IF frequency, and it's connected to the grid of the mixer via a 0.01 capacitor. As usual, I have my analog meter connected to the plate of the output valve. I'll turn it up till we get a reading on the meter. That'll do. I can't put the dummy load on the speaker, it's just too hard. So we have to put up with the noise a bit. That's that one. That's that one. I'll flip it over so I can do the bottom. Alright, I'll just adjust this one. That's it, that was about right. I changed the alignment tool, this one's a bit deeper. And once again, that's pretty much right. Alright, we'll leave that there. So, as usual, I'll go recheck that a few times, make sure they're spot on, and we can just do the RF alignment. I've set up to do the RF, so I've got the gang fully meshed and that should be level. I have the generator on 600. I've connected the generator directly to the antenna through a 200 picofarad capacitor. I'll turn it up a bit and see if we can find the 600 on the dial. It's a bit short, it should be pointing to this dot. So I'll put it on the dot, about there. And the oscillator is back here. Right, that's about right. I'll take it up to 1500, which should be that dot there, I think. Change this to 15. That's pretty good. Yeah, okay, I'll leave that. So I'll go back to 600. 600 on the generator. This one here is the antenna coil. We'll see if we get any with that one. Looks like it's pretty much on the peak there. Alright, we'll leave that. So I'll go up to 15. 15 on the generator. All that's left to do is just trim this antenna trimmer on top. That'll do. That's it. The owner just contacted me and said, yep, fix the transformer, whatever it needs. I was talking to my friend and mentor and he said there's a way of checking the temperature rise inside the transformer. Now I've been doing it on the outside, but he says this is a good way of doing it, and if you're changing a transformer, it's a fine way to make sure that it's not getting too hot, that's capable of supplying the power. So I'm going to do the little test. Look, this is really a bit of a giggle for this particular application, but it's good to know for the future. What he said was measure the cold resistance of the inner winding and write that down, run it till it gets hot, and then measure the resistance again with it hot, and there's a little formula to apply, and that'll tell you the temperature rise. I've connected my multimeter across the primary there, and it's reading 38.68. So that'll be T cold, so it'll be R cold, won't it? So that's resistance cold. I'll put the radio on for an hour or so and we'll measure it again. It's been about nearly 1 hour 50 minutes this has been running. So the resistance now is 44.45. Give me a second, I'll write the formula out. There's the formula there, so it's resistance hot, which is 44.45. Cold is 38.68. And we divide that by resistance cold, which was 38.68, multiplied by 0.00393 equals, that's 5.77, 0.00393 equals 0.1520124. So we divide that by that. So 5.77 divided by memory recall, where is it? There it is, equals 37. We'll make it 38. So that's 38 degrees. It's gone up. My friend told me that it should be less than 45, so it's actually within limits. But I got to say, this entire chassis is red hot. That's got to be running at near 50 degrees, and that's been off for a few minutes now. Well, that was an interesting little experiment, but I still think I need to pull it apart because it's still running way too hot. As I said, you can't leave your hand there, that's crazy. I've done a bit more testing on this and I'm pretty sure there's something wrong with it. I took everything off except the input to the primary, and it's pulling far too much current. and in that state after about an hour it was well over 40 degrees, so it shouldn't be that hot. So I'm going to pull it apart, and if there's nothing wrong with it, well, I'll just rewinding a perfectly good transformer. Let me go outside, I'll take all these laminations out, I'll come back, we'll mount it on the winding machine and see what I can do. I've removed the laminations and I've mounted it in some little blocks. I had to make new ones up, so I'm going to try and dismantle it. Not quite sure how. Let's try down here and get something a bit heavier. Now this has all been glued together with wax, which isn't going to help. I'll just snip these wires. Right. Right, I found the end of the wire and I'm just going to measure it. I've ordered new wire. This measured up while it was in the transformer as 0.2 millimetre, and that's what it is there, 2 millimetre or 0.2. So I'll write that down. I'll reset my counter and I'll just count the number of turns. I think I've come to the end here. I thought I had another wrap to go, so I didn't turn the camera back on. Anyway, yeah, that's the end of it. Alright, I'll work out the turns. We need 5 of these 9s, then we minus 9, 8, 5, 6, 5 equals 1434. So that's 1434 turns. Here's the wire I just took off, and you can see the enamels falling off. I'll put my meter across 2 of the bare bits there, and yep, sure enough it's a short circuit. So I feel somewhat vindicated, I think. Alright, I need to try and dig down a bit deeper and find the next layer. Okay, I've got it. I thought the next winding was going to be the primary, but it's the 6.3. Alright, so I'll wind this off. I better reset my counter first. So I'll reset that. Alright, I'll just start unwinding it. This wire is the same deal, the enamel's just falling off, it's just flaking off. I measured this wire at 0.8 mil, and so we got 30 plus 50 is 80, yeah, so 0.8 mil. And it's dropped down 37 or 38 really, because it's from 0. That should be the primary here. I'll just dig that one out and this will be it. I should be able to grab this, hopefully. No, there's another one here. Alright, I think I've got it. There it is. Alright. So reset the counter again. Alright, I hope it'll cut through. Should be alright once it gets going. There we go. I'm almost at the end and I can't see any sort of burn marks or anything. So I'm not sure, you know, I was waiting for an aha moment, but I don't think it's going to occur. But this wire definitely smells burnt and it's just flaking off. The enamel's just falling off. And that's the end of it. As with the other wire, the enamel's just falling off on my fingers here. I'll measure it. I think it should be 32 mil. And there it is, 32 millimeters. Or 0.32 millimeters. I may not have had the camera on it last time. I wrote down here for the 6.3, 0.80 millimeters and 38 turns. This one is 0.032 and the turns are 1353 actually. So that's 1353. This actually should be 5. I counted down from 9999, it should have been zeros. I'm going to go and clean all this mess up and set up to start the rewind. Before I start the rewind, I found out something. This is the schematic for my radio. This is exactly how my radio is, even down to wiring differences here. This is it. So this is what I was looking for, 230 volts here and 6.3 volts for the filaments. Now this is dated 1961, this drawing. I've got another drawing here. This one's dated 58 and it's got 245 instead of 230, and I was reading 253 I think, so that would have been alright. And the filament voltage is 5.5 volts. So that's pretty much what I had. I had 253 I think and 5.6 and 5.7, something like that. So I'm wondering if in production they used an old transformer in this radio, or someone's replaced the original transformer with a replacement one from an older radio. I really don't know what to think now, but what I'm going to do is rewind this transformer to give me the 230 and the 6.3 as per the original drawing. I've done a lot of calculating in the last few days while I was waiting for the wire, and I think I've got it worked out. So I'm going to give it a go and see what happens. In other news, I've made a slightly larger pulley to put on the winder, so that should have dropped the RPM a little bit. And I've plugged it into the variac, so it's now powered through the variac and I can control the voltage and control the speed. But that created another problem, that the voltage was so low these lights wouldn't work. But what I did was break into this and wire this directly into the 230 volts we've got. So that's bright, but the motor's still working on about 92 volts. To work all this out, I downloaded a little calculator here. It was $10 online, so that was alright, I didn't mind paying that. There are other calculators around, but this one works pretty well, and the other ones were a bit too complex for me. So I fed in all the numbers, and I need 1663 for the primary, 1407 for the secondary, and 44 for the 6.3. Alright, I'm ready to start winding. I'm going to try and reuse this tag strip that they had on there, and I've marked where the particular windings need to come out. So there's primary and primary. The primary was the first winding on there, so I'll put that on first. I've put some heat shrink on the wire here, so I'll put that there, and I should be able to stick that on. Alright, I'll reset the counter, so I've got zeros there, and now I can very carefully start winding this. And I'll just do the first few by hands to make sure I secure that end. Now before I start the machine, I'll just take this wire out of the way. I don't want to drag it in while I'm winding. Okay, I'll start winding. This won't end up, running like it did from the factory. I can't do that. It'll just be all over the place. But that's okay. Well, I'm looking for 1663. I'm just coming up to it now. There it is. I ran out of wire, so I've had to put a join in there, which is really annoying. But it should have been enough, I thought, but it obviously wasn't. So once again, I'll put a bit of heat shrink on there and just bring that wire over. I'll put a bit of tape on there to hold that. I'll just tape that down. It's going to make a bit of a lump, unfortunately. Okay. I'm putting a thick layer on here because the 6.3 winding is going on next. Alright, that looks pretty good. I've got some 1mm wire here. I think I'll just go straight down with this one. I don't think I need to worry about running across the other winding. So I'll cover that again. And that's going to come out here. If you can see that, it says ground. So I'm going to do this manually. I won't turn the machine on. Oh, I forgot to reset this. So we've got 3 on there now. Oh, we've got 2 wraps on. I'll just take 2 off. So I'm after 44. I really want to go 45, give it a bit extra. And seeing we've got 2 wraps on, I will take off 2. Okay, so I'm coming up to 40. I wanted 44, but I already had 2 on there, but I actually want 45, so I'm going to go to 43. So I need to go off there. I wonder if I should do another one. No, there's 44. I've got a bit of heat shrink on there, and I'll just bend that around there. And once again, some tape getting right into the edge there. Here's the secondary going to go on now. I'll just put that there. And a bit of tape to hold it. And I'll put the tape over it again to just cover it so I don't pick it up with the new wire. Now reset the timer this time, or the counter. Alright, should be right to go. I need 1407 on this one. And just coming up to 1407 now. Whoops, went past. Alright, I'll wind a bit off. Alright, that's going to come out over here with the ground and run a bit of heat shrink up there. Let's put a bit of tape to hold that one as well. A little bit on there. So once again, I'll just wrap some tape all the way around here. Make sure I cover all the wire right up to the edge. Alright, that's it. I forgot to mention I put press board in here to make sides for this bobbin because it didn't have any sides, and I'm going to put some hot glue around there just to adhere the press board to the coil. Now this is my idea, it's not something you would normally do, I wouldn't think, but I do not want the press board coming away and then exposing the wires. And I've done the other side as well. I'll take it out of the mat now and I'll try and fit this on. And I think that's going to fit all right, so I'll put some hot glue on there, glue it down, then put some tape around it. I'll just let that cure for a second. Now I'll just have to scrape the enamel off all these wires, connect them to their little terminals there, and we'll test it. I've soldered all the wires on. I'll check them for continuity. This should be 0, this is 6.3, yeah, so just about a short, and this should be maybe 100 and 114. Here's the primary. It should be 100 and, about 50 odd. Yeah, 52. Okay, fantastic. All right, I'm going to put the laminations in. I've brought in some of the laminations from my workshop. Now these are called E&I style laminations. So they go like that. Another one comes in from around the other side, like that, and then the eyes fill in that little gap there. So you just rinse and repeat, do the same again, put a little eye in there, and then another E. Just keep going till you build up. Now, when I put it together, I won't put any of the eyes in till later. I'll keep them all out. I'll just put the E's in, and when I get up to fairly full, I'll start working backwards from the other end and then fill in from the center, otherwise you damage the bobbin. And once I've got all the E's in, I'll go through and just tap in these eyes and that'll fill it out. It's a bit easier without all the eyes in there, you get lose track. So that's what I'll do now. I'll go in my workshop and I'll assemble all these E's and I's. Okay, the transformer's back in. I've just got some temporary power wires on there and put the main cord back on later. And we'll see what it does. It's working. About 140 volts I want. Right, I'll let it warm up for a few minutes. This one's supposed to be 230 I'm looking for here. 225, that'll do. The plate here was supposed to be 200. 202, that's perfect. This one here was supposed to be 180. 181 or 83, okay. This here should be about 180 odd, about 80 I mean. 85, that'll do. Now the 6.3, this might be a little low actually. No, it's not bad. 6.28, it's not bad at all. Alright, so those voltages are perfect. There was a fair bit of guessing going on because it's only a half-wave rectifier and I wasn't sure what the effect was going to be. So you would normally multiply by 1.4 to get what the AC is going to convert into DC. So I assumed it was going to be about half of that rate. So that's worked out pretty good. I'll let it run for an hour or so. I've got to see how hot that transformer gets. I've got to put the power cord on and I need to put the dial plate back on. This has been running for about an hour and a half and I've stuck a temperature probe in there and I can tell you without looking at the temperature it's fine. It's just warm and the chassis is not getting hot like it was. And it's got 44 or 45 degrees in there. The room temperature is probably about 27. So I think that's good. I'm not sure what was wrong with the old one though. I don't know why that was getting so hot. I think that's about all I need to do to this. I think I can send it back.
I think some years when you have a really strong field, a lot of people watch them. Other years, not so much, and I think this is one of those other years.
There it is. It's a Philco. It's an Alabama model. It was made in the late 50s, early 60s, and works really nicely, really nice. It actually sounds pretty good, even without the case on it. This was supposed to be a nice, simple repair, but the transformer added a bit of work. Anyway, it's working really well now, and I really enjoyed doing this little New Zealand radio. And if you enjoyed watching it, I hope you can join me for my next radio adventure.
G'day. I know what you're thinking. Why is that bird boarding an Air New Zealand flight to Los Angeles? Well, I used to do all my own long-haul flying, but this migrating across the Pacific thing is hard work. How long till we land, mate?
Mate, about 17 days. Isn't the weather nice?
Where'd he go? With Air New Zealand, I can fly to North or South America while soaking up some great Kiwi hospitality.
Kia ora. Welcome on board.
Sorry? Oh, and as for their hilarious accent, welcome aboard. Ah, hi there, I'm Dave. Off to LA? Me too. Last time I was there, funny thing happened to me. And that's why I don't take bread from strangers. Oh, great idea. Hey, check it out. Loads of movies, TV shows, games, and music.
Good evening, sir. What can I offer you for dinner? I've got the chicken couscous or... sorry, vegetable curry it is.
Bingo. Delicious Kiwi cuisine. Have you got anything Australian? Like Pav? Air New Zealand is also the first airline in the world to have the economy sky couch. Super comfy, right? I'm just using Seat Chat to say g'day to my old mate Kevin. He travels in business premier. Did you know these guys were voted best airline in the world 3 years in a row? Probably not. Kiwis, eh? Never blow their own trumpet. Except about the rugby.
Thank you. See you again.
Sure will. OMG. Guanchan, you look very familiar. You an actor?
Discover a better way to fly to North and South America.
Kia ora, sir.
G'day.
How are you today? Travelling to LA?
Yeah.